My name is John Newquist, and we're going to talk about environmental management today. This is one of the topics on the certification exams. Again, I will have sample questions. I never take the actual exam question. I take the concept and I make a question related to the concept. So that's why, these are the issues you want to know about. Environmental management is a topic on the CSP domain 7, ASP domain 7, um, SMS domain 23. And you could get literally 20 questions on the CSP portion on this test. And we talk about the water cycle. We want to make sure that we have plenty of clean water. So water, comes in the clouds. When it rains, it goes into the mountains, the valleys, everything else. The runoff goes into the river and then eventually into lakes or oceans. And, all the cycle of life depends on it, from the fish in the water to the trees. And so the water cycle is important in that we need to make sure it's got plenty of water and that we don't have a lot of issues with the contamination of the water. So when they talk about water management, it's protecting the public health and the ecosystem and trying to take the wastewater and storm handling and make it good for the people that drink. So, countries will have to have environmental policy, planning, implementation, checking the water constantly for contamination and management reviews. So when I was in Cambodia this last year, that was one of the things I watched them do is they've got different people helping them out on the water quality, checking out for all the different contaminants. Now they were only monitoring for a certain amount of contaminants, like E. coli and bacteria and things like that. But Chicago water treatment plant, which is Jardine, which is the largest in the world, they monitor about 180 contaminants, anywhere from medical drugs to lead and all your other chemicals. Stormwater management, when they talk about it, we're collecting the rainfall and we're going to get it into the area where it can come into our treatment plant. And the trouble is that when you have farmers and crops, there could be some pesticide residue and pollutants that are going to be in the ground that they're using for the area. Some places that I've been to, there's lead contamination in the soil or arsenic contamination in the soil, and that's going to be an issue for drinking water. But the idea is that you're talking about green infrastructure, something that you can make to help collect more of the water and letting, areas that have a tough issue with water and short supplies to keep track of it, as well as, make sure it's not going to be, evaporating and nobody gets to use it. So the knowledge checks, you can answer in chat. Rivers and lakes get most of their fresh water from precipitation, oceans, wells, or aquifers. Chat is your three little dots at the bottom. Anybody brave? Okay. Okay. And the answer is precipitation. Okay. That's just a simple question, and like I said, some of these you're thinking, well, why is that safety? Well, it's environmental. It's an area they want you to know. I don't deal a lot with environmental. There's consultants that deal with it, but if you're in charge of EHS, environmental safety and health, you may need to know how to do permitting in your particular country. How do you get a permit to do storage of material outside, what you can put in the river, what you can put into the discharge, and things like that. Wastewater management, now the water is going to be used in the homes, industry, and it's going to go down the drain, and we want to try to treat it and possibly reuse it. The trouble is, it's going to be everything that people put down in the sink and flush down the toilet. So a typical a treatment plant, we're going to have an area where they call primary treatment, where it's going to try to settle out all the solids, and then we do secondary treatment where we're going to get the contaminants out of it, and then solids will be digested and possibly reused. And then the final treatment of the water is to test it and verify it's good. It can go back into the river, or it can go back into possibly drinking water. So a lot of money in the treatment plants. It has to have a lot of resource to build one. So you're always going to get a question, environmental, on the hierarchy of convention. The first three, the idea is try to reduce the amount of waste that you're going to generate. For example, if we're going to use a lot of water to go in and cool a process, Could we do it with a mist? Do we need to have it so high? Could we use a coolant? Reuse the product over, like we reuse a lot of material that can be used over and over. If it's not drinking water, it's just water. We can recycle the water into the process again. And recycling, a lot of people are familiar with it. You take aluminum cans and you melt them down and you remake aluminum cans again. And then, of course, we want to recover the valuable metals. Like in electronic components, you've got gold, copper, silver, and other metals that we want to get out of it. So some people call it, recycling, but I call it recovering the metals in that case because the plastic part isn't getting recycled. But then we dispose of it, into a landfill. So the idea is that if we can make a lot of the footprint smaller, we're not disposing too much into the limited spaces of the landfills. But you're going to have to know that cycle, and you got to know what the priorities are. So it's always going to be reduced the amount of, waste that we're generating. So which is the option is considered the least preferred? Now they're not going to give you all 5 of them. A lot of times they'll just give you 3 of them or 4 of them, and they're going to ask you in this one, what do we want to do as a least preferred method for the hierarchy of conservation? And you can imagine there's going to be easily 20, 15 questions of variance on this one. Again, landfill. Remember, disposal in a landfill is the least desired option. That means we couldn't reuse the product. So I go to these landfills, and one of the things that we see a lot of times is cardboard and paper, which can be recycled, plastic bags, which can be recycled, and that's where the community has to be involved, because if they don't get involved, then we're going to put this into a fixed finite site of so much volume, and it's just wasted space. So we want to get into the situation where we can recycle most of the plastics and things like that are compostable, like cardboard, paper. We can do recycling of those even.
So John,
Yes.
why not the first option, compositing? Compositing, why can't we select that part?
Well, it is. It is. Again, you're going to be reusing it, and that's fine. If you're taking a product that could be composted, like paper or newspaper, you can compost that and be used again for soil and everything else. We don't want to put it in the disposal method, which is in a landfill. So there's no benefit of this stuff going in a landfill because it's just wasted space. Now with waste disposal, the land the land disposal restrictions are all over, depending on what country you're in. I've been in countries where there's just open waste storage, and that's no good for anybody because the products and the liquids seep into the water table, which then contaminates the water table. So, good, proper disposal of, all the wastes are in there. So, you're going to go and treat it. You can have places that can treat even medical waste, where they bring in the material and they may have an incinerator that's going to, burn some of the product away because, your fluids that are contaminated are usually not going to be recyclable into water and other things. You're just going to probably incinerate it. And then some of the stuff that will be burnt will have gases like methane or other products, and we can use that and possibly sell that. I see a lot of landfills, they just burn the methane off, which is to me a waste. You could capture the methane and process it, which I see other plants doing it. But it's an issue of these landfills are, they've been there for a while. They don't want to put the money to get it, and they don't think the investment's worth the money. So whereas other ones, where it's designed to be captured right away, they do sell it and make money on it that way. So what's a common requirement under typical land disposal regulations? Prohibit disposal of waste if it's greater than 100 pounds. Prohibit disposal of waste if it's greater than 1,000 pounds. Disposal of waste is prohibited on land. Prohibiting disposal of hazardous waste on land without prior treatment. That's a tough question, and you have to kind of think about, if you think about it like the global area, what would your country require or your city require? Okay. This is a bad question, but this is they want it treated. They Prohibit, C is not a bad answer, but the idea is that we can dispose of composted paper and cardboard if it's been treated, right? It's got no hazardous, liquids on it or anything else like that. We could, put it on there. Some people would say C is a better answer, but this is the idea: is they want you to do treatment of any disposal if it's got a potential that it's going to be a problem. So it's kind of like a trick question in a way, and I look at something like that. But that's the idea. They always want to treat it, and you're always going to hear water treatment and everything else. With air quality, it's measuring the cleanliness of the air. And again, the EPA in the United States started in 1970. Before that, you could have a coal plant or any other facility burning oil or coal or anything else pollute the air with big black toxic smoke. And again, they know on the air quality index that there are people that are more sensitive to the pollutants. We can also have smoke and fires. I'm watching the Chilean fire where they've already had several hundred homes gone, people have died, and people are breathing that toxic smoke from the forest. And that's not going to be good at all. So the sources of air pollution, this is a common question they'll ask you, is where would be sources? And typically industrial emissions are going to be up there along with vehicle exhaust. I've been in cities where the vehicle exhaust is all based on diesel or gasoline fuel, and it is black smoke. It is very toxic. You choke in it. And I've been in other cities where they're using hydrogen, natural gas, which burns clean. Not a problem with the air at all. So it depends on where you're at. Energy production, coal plants typically were always black toxic smoke, but they can put scrubbers in there and they can put other devices to limit the black smoke coming out of it to convert it to carbon dioxide and water vapor. Agriculture activities, of course, they did a study where they said the cows can generate a lot of methane from their processing of their food that they eat. And of course, construction, if you got a building with silica, asbestos, lead, and you demolish it, then it could be quite a bit in the air surrounding community. So the key pollutants, this is a common question they'll ask you about air management. They're going to ask you what are the toxic things that you don't want in the air, and you don't want particulate matter like smoke. You get into all the things. If you had the forest fires, we've had a lot of forest fires where the people in this communities have to wear an N95 respirator just because the particles in the air are so thick, and it's choking and blinding. But we don't want sulfur products as well as other nitrogen oxides in the air. Carbon monoxide is a poison. We don't want that in the air. It'll come from products of combustion. And then VOCs, volatile organic compounds. I always see them in paints where they have a lot of odor, a lot of volatile chemicals that are evaporating, which is not good. And then ozone, technically depletes the layer around the earth, and that's going to be an issue. So these are the pollutants that a lot of people worry about, and there could be some natural, from fires, that's a natural source, but there's other ones that come in there. And there's a lot of stuff, you could have sulfuric acid and everything else. But these are the ones that a lot of people watch. Now, the health impacts is obviously, if you think about the worst would be, death, but you can get lung problems, cardiac effects, chronic pulmonary function disease where all you're doing is talking and you cough every so often, that it's a problem. Asthmatic issues and everything else. And again, these issues can affect, because, when you look at something like smoke or any of these particles, not a lot of research to say, if you get exposed to this level of smoke, this is the effect. You can do that with some chemicals, but we don't see that too much with these other issues. How much sulfur dioxide in the air does it take you to have a respiratory issue? And we don't really have a lot of good data on some of those issues when they combine with all the other stuff that's in the air. So the best practices, for air quality, you're always going to get a question on a best practice. What are the good things to do? Well, you want to do, regulatory compliance. Every country should have their version of an environmental protection agency. They're going to set up some minimum standards for it. You're going to control emissions. And, a lot of these are done by cities and individual townships and provinces and everything else where They said, you know what, we're going to go to electric vehicles, or we're going to go to hydrogen, natural gas vehicles. They monitor the air. I've been in a lot of places where they monitor outside the facility to verify that they're not putting something like ethylene oxide or other products of combustion out in the community, which could be problems. You don't want cancer-causing chemicals being released from an industrial facility. That's not going to be good for anybody. And every area that does air quality management will have limits they can have, much lower than OSHA. And the reason is you're out exposed to this 24/7, where OSHA you might only be 8 hours a week for 40 hours a week. Again, they always promote what you can do alternative to driving a combustion engine, like electric vehicles, walking, and everything else. And then green infrastructure, trying to make sure you put so much trees, because it is a benefit. They take the carbon dioxide out of the air, and it's a good thing for a lot of environments to have a lot of good trees. And again, we want to try to reduce the energy efficiency. I was watching Ford yesterday, and Ford was talking on their trucks that the hybrid truck, which can get sometimes exceptional gas mileages in the 40s and 50 miles per gallon, that's the number one vehicle, then the combustion engine, then the electric. And that's just showing you that people are looking at not only the price of the truck, but the type of mechanism that's powering it. And of course, education. There's always going to be education. What this issue happens. We want to get the pollution down. We want to try to make sure the emissions are low. Therefore, we're not going to have toxic air. So under the Clean Air Act, and you don't have to, you used to be they would give you very specific questions on it. Now they're going to have 6 criteria for pollutants, and this is common in a lot of countries: lead, carbon dioxide, sulfur dioxide, nitrogen oxide, ozone, and what other one? What other one did I mention? Very good. Particulate matter. That's kind of tough when they give you just PM, but
But John, in this one we were having like VOCs also.
yes,
That was also one of the
right. But this is a subtle one, because you're right. You could regulate asbestos in there, VOCs, but the issue of the Clean Air Act was the particulate, the smoke from the factories. That's what the idea is, of get rid of that. And these are tougher questions. But that's where a lot of times you'll know it's one of these two, and that's why I show the slide is particulate matter is usually the number one thing countries come right after, because you don't want to be in a smoky, choking environment. VOCs, not going to be as many as you think it is, but factories will release, if you're making chemicals, some VOCs, but a lot of people burning fuel can release particulate matter, and that's how you manage it. Now they're going to ask you some questions about some of the big environmental ones. This is a change in the last 5 years too. I want to say, if you would have took the test 10 years ago, you never got one of these. Now it's kind of going through it, and I'm only going to give you 2 knowledge checks on them. You should know something about each one of these tragedies. Bhopal was in India. It released methyl isocyanide gas, and it was like a cloud, as they said, and people were running, and they had, that day 3,000 people get killed. Exposures, long-term deaths 15,000. But what they don't talk about is 500,000 people got affected. Some got blindness, some got cancers and other diseases, and they sued this Union Carbide LLC and got about $500 a person. That's not a lot of money when you're blind, or got cancer. Chernobyl was the big one up in Ukraine, which was then part of the Soviet Union before it broke up in the late 80s. And again, it was a nuclear power plant. There's an excellent HBO series that talked about this, and it released a lot of particles. I remember this very clearly because Sweden was having their radiation meters go off, and they couldn't figure out why they were going off. And you start questioning the meters, and then they started realizing there's so much radiation in the air from the Chernobyl plant, which is 1,000 some kilometers away, that it was very toxic. You don't want to breathe radon or radioactive gas, because it's going to affect everything on your body. And so that was an issue. There was an explosion and a fire, and then they tried to enclose it. Today it's enclosed. The core area is still radioactive, and They ended up moving about 350,000 people. When I went over to Ukraine, there's like a 25-kilometer exclusion zone. You can't get within it. You know, you could drive it, but you know, they post it because they had to move everybody out of there because it was such a bad radiation event. Exxon Valdez is one for the environment because when the 11 million gallon tanker split in half, it affected 1,300 miles of coastline. And this is what it was like. Black oil killed everything from ducks to fish to anybody, creature that was in that thing. Took forever to clean up. And, you know, I mean, it would be billions of dollars to clean up that today. But it was an issue, you know, again, a lot of it went back to the type of ship. It wasn't a double hull ship, it was a single hull. And but it was a disaster in Alaska. So what was the main chemical involved in Bhopal? Was it benzene, methyl isocyanate, sulfur dioxide, or chlorine gas? Okay, excellent. Methyl isocyanate. Then the Deepwater Horizon in the United States, known as the BP oil disaster because it was owned by British Petroleum, which is now, they like to call themselves BP. It was an explosion. I remember it was the seventh, they were going to get a safety award for working so many days without an accident, which is, you know, a whole issue of just the management of the site. But, you know, millions of barrels underground water coming out of the bottom of that area where it was drilled. They couldn't stop it, and it did a lot of damage. Very similar to Exxon Valdez. It started going on the whole coastline of Alabama and Mississippi, Florida, and Texas. A lot of marine damage and stuff, but you can just see it was just a nightmare for, you know, just how you handle that issue. And then, of course, Fukushima nuclear plant. This one was caused by a tsunami, and it hit the plant, which, you know, they had prepared for, but it was way too high, too strong, and then the reactor melted, and of course, you know, there's people that were operators that risked their lives to shut and try to control this, and, you know, didn't make it. But a lot of releases. You know, ships were picking up the radiation in the water, and a lot of people had to be evacuated out of there. Today, when I went over to Japan, you know, like 5 years ago, 25-mile exclusion zone. You know, 100,000 people pulled out of the area, which is a lot, and then a lot of disaster data does. Because remember, you had a tsunami also. That was the immediate crisis, and then they think about 19,000 total affected by a big, huge wave coming in there. They asked, you know, what were the effects on the after disaster? Well, one of the questions they always talk about is that a lot of foreign marine life, you know, being brought to the shores and by the effect of the tsunami coming in, and that was just a side effect of it. You know, I was too more worried about the radiation because that's the issue. When are you going to be able to use that area again? And of course, you know, Japan, it shut down the nuclear industry, and affected Germany, who did shut down their nuclear industry, and now it's starting to come back. So the 2000 earthquakes resulted in tsunamis, raised what concern for countries along the northeastern coast of the Pacific Ocean? So it would be Japan, China, and so on. Oil pollutants damage their shores, hazardous materials reaching their shores, foreign species of marine life being transported to the shores, tons of debris washing ashore. It's a tough question. It's the foreign marine life, you know. Wasn't no oil, remember? No oil. But, you know, if you would have had the question, radiation, I would have chose that answer, but this was not one of your choices. So, again, those 5 events, you need to study a little bit about it and prepare for a question on one of them. Sometimes you don't get any of them, but, so, you know, I see most people get 1 or 2. And, of course, in the United States, we had East Palestine. You know, this issue comes up. The train derailed at the lower left. It had vinyl chloride, which is a known carcinogen, benzene, which is a known carcinogen, and it went into the creeks in the area, then got into the water table, and Norfolk Southern had to dig up all the contaminated earth because now it's saturated with these cancer-causing chemicals and stuff. The air monitoring, when we talk about air monitoring, this is what they've got. They've got a, it's hard to tell because it's kind of enclosed, but it's got a meter and it's sampling the air all around some number. We just set out like maybe 8 meters around a mile, another set of meters around 2 miles, just to see what we're getting to determine what the levels are. Because if your vinyl chloride part per million is 1 for an 8-hour day, and you're running 1,000, you might need to be wearing hazmat material gear. And you should know the 4 different types of hazmat, be level A equipment. So that's the consequence for those in safety and health, that you've got an incident command. There's another module that I've already made on incident command, but this would be an issue where you might have to wear level A with SCBAs and full protective clothing, nothing open to the skin. What's always the major priority at a hazardous material incident: protect the life and safety of the public, protect the critical systems of production, protection of environment and climate, protection of the organization's critical property. Now this is a tough question. There's 2 good answers here. Very good. Your safety people. You're always going to protect the people. I know the environment is important, but they don't want people to die. So they're always going to try to protect the people and then the environment second. So, this is a kind of like a thing. You get in the environmental mode, you think everything's always an environmentalist. This is an example of a question where it wouldn't be. Then they talk about environmental management system. You're always going to get a question on this, some form of some issue on this question. The idea is it's a framework. It's telling you how to manage your system just like safety. You ensure compliance with environmental regulations instead of safety regulations, and seek to improve environmental performance instead of safety performance. So the key components: you're going to develop a policy, and this is for any country or city. You're going to have some planning on what you're going to do to make sure this is going to be done. You implement these procedures and rules, and then you check, and then you have a review of it with your various committees, your cities, or your experts. They want the planned act, check, do by Deming as part of a model in here. So you got to remember, this is a system that's, this chart is very common. You'll get a question related to this chart. It may be on the sequence. After we've done the planning of our environmental policy for our province, what should be the next step? Planning, implementation, check, or management review? The answer would be planning. So you're going to get a question on the sequence, and then the plan, act, check, do is Deming. That's what they use as a basis of it. The benefits of the environmental understanding. Well, the benefits is you get food you can eat. If you don't, everything's contaminated. You don't want to eat food with lead contamination or pesticide contamination and everything else. So idea is that we're going to save our resources and not consume them, and then try to reduce any risk to the public, and as well as the animals and the trees and the land. And then again, you hopefully enhance your reputation and people's confidence in your ability to do this and feel good. And you should save money if you do it right. So what does the acronym PDCA mean when it relates to approach for environmental management system? This is one of those ones you see it and you think, well, I know 2 words, but plan is in every one of them. So yeah, very good. Everybody seems to know that because that's a Deming question, and you always get a Deming question, 1 or 2 in the CSP for sure. And then of course the ISO for environmental is ISO 14001. You got to know your ISOs. There's safety, quality, risk management, and everything else. But there are like 5 ISOs, 6 ISOs you got to know. And again, the idea is that it's a team that would come out and verify that your environmental compliance is important. This is to make the companies get some outside expertise to look at their systems at the company and make sure that they're good, or the community. So EMS must clarify the requirements to make sure the operation is safe, it's a sustainable environment, your footprint of creating problems is low. So what set of processes and practices enable an organization to reduce its environmental impacts? Environmental sustainable system, clean air system, environmental management system, conservation and recovery system. going to be the environmental management system. Always a question on that, or two, or three. Then we got in biohazardous waste. Now this is an area that they added into it about 5-6 years ago. I didn't see the biohazard waste as a environmental type of a question. I always thought it as a bloodborne pathogens question. But they're going to talk about how you dispose of it and as a system to protect the environment. So if it got infectious waste, we got hospitals that do surgery. There's going to be waste products from that. There's people that do work with blood and phlebotomy and labs that do analysis. The blood's got to go somewhere, so you want to have a procedure for dealing with it. And it can include anything from medical waste, work on laboratories with microbiological waste, pathological waste. You're doing work on virus, bacterias, and then prions. I have to say 5 years ago I didn't know what a prion was, but it's an infectious agent that causes brain damage, degeneration, like anything encephalitis based, that's an issue. So I've seen prion on the test now. Not every test, but like every other test, it seems like they ask a question about it. So the idea is that we got a lot of different things that we got to deal with on biohazards. We got needles that are called sharps. Anything we do, cut the skin, poke the skin, is going to be a sharp. And then we got issues of our labs. We got, we've got mold, we've got cultures grown in there to analyze them. What do we do with the waste afterwards? And then pathological waste from blood, urine, saliva, any organ, tissue fluids, and things like that is a pathological waste. And then medical wastes are used bandage or bloodborne pathogen stuff that we go and treat somebody with a bleed. So sometimes they ask you the question, they'll give you gloves and masks are which type of biohazard waste, and they'll give you the sharps, biological, pathological, medical waste, and it would be medical waste. So that's sometimes kind of a question they would ask. And you just got to recognize the 4 different types. How you get rid of it is that you think about segregating it out. That's the ideal. You go in there and you put certain colors, as I always see. When you go in there, solid waste go into red, and then anatomical waste. This is a big hospital or a research facility, and you try to put it in there because it's going to be a little bit different. And then, of course, your sharps go in a white container. Most people just have a sharps container in a factory or a construction site, and that's fine because they're not doing, analysis of molds, viruses, or bodily fluids or anything else like this. But again, you segregate it, you label it properly, then you take it to the place that it's going to do the treatment, and then dispose of it properly, which is considered a biohazardous waste. Now I gave you 4 of them, but now you're only going to have 1 choice in here. Sharps containers and needles, used grease and cooking oil, discarded waste from diagnostic work or research at hospitals, waste from a laboratory that works with infectious agents. Wow. 3 are good. It's not used grease. Waste from a laboratory that works with infectious agents. A sharp container with needles could be medical waste. When I save some of these famous questions, and I can make a good case for A also. Waste from a diagnostic worker in research, C. But they know anything from an infectious laboratory is always going to be biomedical. So this is a tough thing about one of these questions. When you take these tests, you can't flag the test and say, I want this question, I want to bring it up to the board. If I see it and I remember it, I bring it up, and they usually say, they didn't make a mistake. So, but that's a tough, question. Anything on the environmental side, a lot of topics to talk about, and again, you can get a whole degree in environmental engineering and everything else. I'll post it up on YouTube. I appreciate everybody coming in. Next month, we're going to look at doing some of the math and science questions, because a lot of people are having trouble, particularly on the CSP, with the math and science area. Construction seems to do all right with their math and science, but I'm going to focus a little bit more on the CSP side of math and ASP side of math. All right. Thank you very much, everybody. I appreciate it, and I'll see you next month.